Hey Thinksters, and welcome to this video, which is part of my Python one-liners launch book series. This book launched in 2020, and I will basically give away all the content for free in the video format. So you can either buy the book or watch all the videos on YouTube or on the platform you are currently at. And so in this video, in this chapter part, we addressing data science, in particular NumPy, the NumPy library. This is the sixth video of the NumPy series, and today we are going to look into the Argsort function in NumPy. So the Argsort function, why does it exist? Why is it here? How can it help you accomplishing things? So let's have a look at the Argsort function and its use to you. Okay, so this is a Argsort function. Say you have an unsorted array of numbers 10, 6, 8, 2, 5, 4, 9, and 1. So these are the numbers. Here you see the indices. So these are the indices of the array. So it's starting you start counting with 0, obviously. So the first element has index 0. The last element here has index 7. And now these are the unsorted array indices. Okay. So here we have a like 1-to-1 mapping. You have the element 10 maps to the index 0, and the element 1 maps to the index 7, okay? And now you have a sorting algorithm here, and the sorting algorithm can now return two things. It will sort the array, right? So it will sort the array so that the smallest element appears at the beginning and the largest element appears at the end, okay? So this is now the sorted array. It starts with number 1 and number 10, so we have just sorted the elements here. And now we kept the indices. We kept the indices of the original unsorted array. So we kept the index mapping, if you want. So we still have element 10 maps to index 0, which was the case in the unsorted array, and we still have element 1 maps to index 7. Okay, so basically our sorting algorithm, there are two possible results you can have with the sorted algorithm. You can either have the sorted array itself, so it's a new array with the numbers 1, 2, 4, 5, 6, 8, 9, 10, and so these are the numbers sorted in ascending order, or you can return the sorted indices. So these are the original the array indices. So these relate to the original array indices of the unsorted array, and now this sequence of indices give you the sorted list. So if you used those indices, if you accessed your elements in the original array using those indices, then you would get the sorted sequence. And this is the Argsort function. It is all about the Argsort function. And now let's have a look at a practical example where this would be of some use. So say we have like names of some, so we have some sats. I will first give you the data maybe. So we import NumPy as NP, so it's a standard way to import NumPy, and now say we have this data set, so we have data which are the SAT scores for different students, okay? So this is a common data set, it could appear anywhere, yeah? You have a NumPy array, one-dimensional NumPy array, and these are the SAT scores. Actually, I'm not a native US, but I think that there are some scores that rate the capabilities of students or pupils. Okay, so you have the SAT scores, and higher the better. And then you have some names. Also, it's a one-dimensional array, and these names obviously relate to the SAT scores. And now, what if you want to have the names of the top 3 students with the highest SAT scores? Okay, so we don't want to have only the highest SAT scores. Otherwise, we could simply sort this list and then give us the top 3 elements. But we want to have the names of the students with the highest SAT scores. And so there's a nice one-liner that accomplishing this thing. Here I just write one-liner so that you know that the one-liner starts now. And we want to have like the top 3 students. And these should be students now, okay? And if you print result in top 3, then we want to have like the names of the top 3 students, which are so the highest SAT scores. I mean we have Alice, we have Alice has SAT score of 1500. Then we have Frank, who has a SAT score of 1400 something. And then we have Carl, who has a SAT score of 1300. Okay, so this should be the result of our one-liner. Good, so let's do this. So as we want to have the name, we basically want to use the students array. Okay, so we want to have the students array, and now we simply need to determine the indices of the students array. And now say we have obtained a sorted, so we have basically sorted. So maybe let's first start what we want to have here. So we want to sort the students array according to their SAT scores, but we cannot use the sort function itself, because otherwise we would so if you would sort the SAT scores, then we would get obtain a list of sorted numbers, but we want to have the names of those people. Okay, so therefore, but still we want to sort the SAT scores, because this helps us find the students with the highest SAT scores. Okay, so you can then simply pass in NumPy. This is possible. So students is a NumPy array, so you can pass indices. And which indices do you pass? You pass the Argsort, the indices of the sorted. So we sort the SAT scores array, okay, in ascending manner. Now this is ascending, so we start with the smallest element, but we are not really interested in exactly the sorted SAT scores. We are only interested in the indices, because you see there's a one-to-one mapping. So this SAT score is mapped to this student, and this SAT score 1200 relates to Bob. Okay, so therefore, if we have the indices of the sorted SAT scores, then those indices are exactly give us the sorting of the students. Okay, so if you have so say the students with the highest, so if you sort this one, then the small students with the smallest SAT score, this one will have index 0. So this will be the first element of our SAT scores of our sorted SAT scores list. Okay, so this will be the first element of the sorted SAT score list. So therefore, the first element will be, it's like the fifth element in the list, so it's chain. Yeah, so therefore we have this SAT score 989, which is the first element with index 4. So index 0, 1, 2, 3, 4. So this has index 4. So 4 would be the first element of our argsort function. Again, remember, our argsort function returns the sorted indices. Okay, so we have we sort the array and we retain the indices of the original elements. And yeah, so in this case we have 4, which is the index of this element, would be the first element. So 4. So if we now access students of 4 as the first index of our argsort function, students of 4 would be 0, 1, 2, 3, 4. So it would return Jane as the first element of our of this part. Okay, so this will basically give us all the students in an ascending order. So let's print this quickly, and now you see, okay, Jane has the smallest SAT score and Alice has the highest SAT score. Okay, so Alice has a SAT score of 1500. So this gives us a whole array, but we are not interested in the whole array. We are interested only in the top 3. Okay, the top 3. So there's one. So now we use slicing on the resulting array, which I have just shown you, and we use negative slice size to reverse the array. Okay, so now we have reversed the array, basically giving us the student with the highest SAT score, Alice, first. Okay, so let's print this. Now you see Alice is now the first element and Jane is now the last element. So we have simply reversed the order of the elements of our original array. And now we are interested in only the top 3. So therefore, with negative slicing, we also can use negative indexing to the stop. So we have the start, the stop, and the step size arguments to the slice operation. And the stop just gives us last element we want to slice. And remember, we slice from the right, so we slice from the highest element. So from the element that is in the last position in the list to the left, to the first element, because we have negative step size. So therefore we want to have the last one, we want to include the last one, the second last one, the third last one, but not the fourth last one. This -4 points to the fourth last element in the list, but this is excluded, so we are not considering it. Okay, so this gives us the names of the top 3 students, Alice, Frank, and Carl. So let's print it. You see Alice, Frank, and Carl. Okay, so this is a good application of the Argsort algorithm. So if you are interested only in the arguments of the sorted arguments, if you want, the sorted indices, if you want, of the elements in your array, then you can use the Argsort function. So it's quite useful in many settings. And you have also seen another feature here that you can just put a number of indices into the normal Python indexing scheme, NumPy indexing scheme, to return an array with changed order of the elements. Okay, so you just give the indices in the order of their in any order, in any arbitrary order you want, and then in this way you can reorder the array sequence actually. Okay, so this was so I think this was it. That's enough for today. So you have learned about the Argsort function and a practical application of the Argsort function. You have learned about this specific particular indexing, so array indexing in NumPy. You have learned about slicing with negative step size and negative stop index, and yeah, you have I think improved your NumPy skill by quite a bit in this video. Okay, so thanks for listening to this video, and if you want to get more information even and more explanations, then check out the book Coffee Break Python One-Liners, not Coffee Break Python, Python One-Liners, which I just released in 2020. Thanks for watching this video and see you in the next one. Bye.